Hi guys, Dr. Tracy. Here's another video from Chapter 4. This is just a brief introduction to dynamic memory allocation. In this book, it talks about sometimes you create arrays and you don't know how many values you need. Most things are stored in the stack because they are memory locations that are created at runtime through the use of the main function or additional functions. But when you need to pull something into a large storage area and you're not sure how much memory you need to allocate, there's no neat way to be able to do that. So we put it in the heap. And the heap is free store. It's a way that you can allocate values and arrays of any type that you can use later, and you use them according to their pointer location. We establish pointers to point to this location in free memory. But that creates dynamic memory allocation. Here's an example of it right here. This creates an integer of a variable that's a pointer in a memory block of that given type. We use that memory at that location, and when we are done, you have to delete it. That's the only trick in the heap. I always think of the difference between a stack and a heap is like a pile of folded clothes and a pile of dirty clothes. We got to do something with the pile of dirty clothes. We can't just leave it there. But a pile of folded clothes, you can find things because you know where they are, because it's easy to see. And they're created as they're folded, and so they have perfect structure. So if you look at dynamic memory allocation, by establishing a pointer and giving it a name, we can assign a variable to free memory, and then we can use that variable by dereferencing it, pulling out the variable from the location that's given, and then we delete it when it's done. And that is the advantage of being able to manage memory. One of the key reasons why C++ is a very powerful language that's used for lots of different programmings is because of that ability to modify memory, to be able to change and use memory as needed and delete it when not needed, so that certain areas of the memory block will be freed up. The rest of this text, and I'm pulling this directly from the text, shows some common memory allocation errors and the things that might go wrong if you try to do this. For example, in the first one, by creating this pointer to p as an integer and then assigning it a value of 5, there was no new call to a new integer, and so that would produce an error. In the second one, it's creating an a variable as a new integer and then assigning it a value of 5, but then the memory block is never deleted. Looking through these errors can help you to understand how to program using something like this to create common memory allocation errors. As you go through each of these examples of code, then you can run and check what they do. So here is a program that demonstrates dynamic memory allocation. The first thing that it does is it creates a pointer, which is going to point to a double, which knows how much of that heap that we're going to be able to use for our memory. That account pointer is dereferenced to assign a value, and then it will assign that value. Now with an integer n equals 10, we're going to create another pointer in the heap for the value of 10. And then it's going to loop through the array of those elements that were used. So let's see how that runs. When you look at the program, what's happening is it has allocated an array of size of 10 because it's found these memory locations and assigned the value. And then it was able to take each one of the value, add it to the previous value. And now there would be room for an additional element based on what happens in right down here where the last element in the array is deleted. Notice there's the delete statement, but the delete just says account pointer because all it needs to delete is the first element of an array for an array to be gone. The data values are still there. They're just flagged that they can be written over. And so and they're taken out of memory and they're no longer being used. Hope this was helpful. I've got a few more. Let me know if you have any questions.